In this video, I want to talk about congruency, or what the word congruent means and how that helps us in looking at certain figures like we see here with a series of intersecting lines so that we can identify the measure of angles based on relationships in which they are congruent. So the first thing we should make sure that we understand is what the word congruent means. Congruent essentially means equal. Okay, so to be congruent means to be equal. It really means more specifically than that, the same size and the same shape. But for our purposes, we'll just think of when we see the word congruent, it means that things are equal. Now, the symbol that we use for congruent looks like the equal sign, but we put a little squiggly above it like so, okay? So it's an equal sign and this little squiggly up above it. That is the symbol we will use for congruent. Because again, congruent means something more than just equal, but for our purposes, that's what we'll say. So actually, we'll make a note of that down here. So we really mean same size and shape. Now that's more important when we start talking about actual shapes and saying that they're congruent. So if I'm comparing triangles and I want to say they're congruent, I'm saying that those triangles are exact twins of each other. They are the same size and the same shape. For our purposes with angles, they are the same size, so they are equal. Okay? That being said, I want to move on to within geometry, the two types of situations that we typically come up with. We come up with intersecting lines. You can see here there is one line known as line AB and another line known as OP, line OP, and they intersect right there at point C. Now, in this diagram, there are essentially four angles being represented. You can say that there's angle OCB. So if I wanted to write that, that's angle OCB. And across from it, there's angle ACP. Now remember, each of these angles I could say in reverse. I could say this is angle BCO, and down below I could say this is angle PCA. Now, these two angles here that are formed by these intersecting lines are what we refer to as vertical angles. Vertical angles are angles across from each other. So angles across from each other when we see intersecting lines. So why don't we actually say this? Angles opposite each other formed by intersecting lines. So these angles are opposite each other. Okay. Now what's important about this is that these angles will be congruent. Okay, so this is really key. These angles are congruent, which means they're equal. So if I know the measure of angle OCB, automatically I know the measure of angle ACP. Now there's not just one pair of congruent angles that are vertical angles, there's actually a second pair. That second pair of congruent angles, because of being vertical, are angle OCA, and directly across from it, opposite from it, angle BCP. So the angles I've written in red are congruent because they're vertical. They're angles opposite each other formed by these intersecting lines. And the angles I've written in blue are congruent to each other. Their measures are equal to each other as well. Now, there's also another series of angles that show up in this diagram, and those are called adjacent angles, okay? Those are angles sharing a side. Angles that share a side formed by intersecting lines. So an example of adjacent angles would be one of these red angles along with one of these blue angles together. So for example, angle OCB is adjacent to angle BCP because they share this side right here. They share that side of CB with each other. Now, what we should be able to recognize here, since we've talked about these types of angles, these angles together make a straight angle, which means that they add up to 180. Now, there's a word for that that we know, which is supplementary. So we want to make a note of that. These angles are supplementary. Remember that adds to 180. Okay, so that's really helpful information to know. So if I go back up to this diagram, with these two intersecting lines, there's 1, 2, 3, 4 angles. If I know just one of these angles, I know all four, because if I know, say, angle OCB, I know that angle ACP is congruent to it because they're vertical angles. And I also know the measure of angle OCA because it's adjacent, meaning that it's supplementary to either of those two other angles. So I can subtract the known measure of one angle from 180 and figure out the missing angle. Okay? So we're going to use that information shortly when we get down to the bottom. So let's move on to the other situation. I have a pair of parallel lines. Now we should know that these lines are parallel because they're marked with those double tick marks. Those little tick marks tell us without a doubt that line A and line B are parallel to each other, so they will never intersect. But there is this line here known as line T, and that's really important to understand. That line is known as a transversal. That line is known as a transversal. A transversal is a line that intersects a pair of parallel lines. A transversal is a line that intersects parallel lines. So line T is my transversal. And you notice that it creates 1, 2, 3, 4 angles on top and another 4 angles on the bottom, which are numbered angles 5, angle 6, angle 7, and angle 8. Now, what's important to notice here is that there are actually two groups of angles. There is a group of acute angles, which are all congruent. And we can see what those angles are. We can tell visually that these angles being acute are less than 90 degrees. So what angles are those? That's angle 1, angle 3, which by the way is vertical to angle 1 because these lines intersect. And then down below there's angle 5. And once again, angle 7. So there's angle 1, angle 3, angle 5, angle 7. Now, to go along with that, there's another group of 4 congruent angles that are obtuse. There's another 4 angles that are obtuse, and those are congruent with each other. Now, notice angle 1, if I start with angle 2, angle 1 is adjacent to angle 2. Notice how we're using the information from the earlier diagram. Angle 1 and angle 2 are adjacent because they share this side right here. So that tells us those angles are supplementary. So angle 1, one of the obtuse angles, added with angle 1, one of the acute angles, will always give us a total of 180. Putting that aside for a moment, just looking at the 4 obtuse angles, then angle 2 is congruent with angle 4. which is also congruent with another obtuse angle in this diagram, angle 6, and is finally congruent with angle 8. So I'm going to leave you to actually use all of that information, okay? And you can go back and refer back to this video. So going back to figure number 1, or going back to the intersecting lines, going back to this information up here, you're going to be told that angle ACO is 67 degrees, and you're going to be asked to find a couple of the other angle measures within the diagram. Likewise, in this set of problems down below, you're told that angle number 4 is 136 degrees, and you're going to use that information along with what was explained in this video to help you figure out the measures of angle 3 and angle 6. The other thing I'm going to ask you to do is to answer the questions on the Google form that will be attached on Classroom as well, just to review the vocabulary. So there was a lot of vocabulary here, so I want to make sure that you got a clear understanding of the various terminology: vertical angles, adjacent angles, transversal, reminding you of what acute angles are and what obtuse angles are, okay? So answer the 2 questions at the bottom of these notes, and then answer the questions on the Google form. And we'll come back and do more review in class.